Hi. Okay, today we're going to talk about motion maps. Now, a motion map is basically a representation of motion using vectors. And vectors are the arrows that you see right here. So, for instance, let's take a second and look at this car. You can see the car is evenly spaced, and the spacing stays the same throughout. So it's a nice even constant velocity. Okay, now this is like a strobe light, where it flashes black, white, black, white. You can see it, you can't see it, kind of like they have in those haunted houses and scary movies and stuff. So, you see the car here, then you see the car here, then you see the car there, and it just continues. All right. Now, to represent the car, instead of having to draw this car so many times, physicists decided to just create vectors and motion maps. So, you start by drawing the number line with an X, and it always points in the positive direction. There's always an arrowhead at the end. So this is important, and this is important on the number line. Now, when you draw a motion map, the dot on the end represents position, the length of the arrow represents magnitude, and the arrowhead represents direction. Okay? So that's how a vector is formed. Remember, we watched the Despicable Me video and he talked about a vector is a quantity of measurement represented by an arrow that shows magnitude and direction. Magnitude, again, is number, and direction can be positive or negative. All right. So when you look at this car, you can see it's traveling pretty slow because the distance between these points really, really close. Now, if you look here, this car has a greater distance between it as it travels in this 3-second period. That's why this arrow is longer than that arrow. Longer arrow represent faster speed. I can't spell. Faster speed. Okay? Now, shorter arrows slower speed. Okay? Now, if you notice, this car is going to the left. The number line still remains positive, but now the vectors are pointing in the opposite direction. You also start your motion map away from the origin because the car is traveling toward the origin. So this is the beginning, and this is the end. All right? Where up here, this was the beginning, and this was the end. All right? Now, let's look at this portion. We're starting here, and the car is going to the right, positive. This is positive constant velocity. The car stops for 2 seconds. And then heads back toward the origin at a slower speed. You can see it slower because the arrows are shorter than the initial arrows. So basically what's happening is the car has made a U-turn, but the car stopped and then made a U-turn. Okay? So it's like that. But in physics, we never curve arrows. Vectors travel in a straight line. Everything in physics travels in a straight line. The movie Wanted with Angelina Jolie is an inaccurate representation of physics. The laws of physics hold true. That's why they're called laws. You can't curve a vector. You throw something, it travels in a straight line path, unless a force is acting on it. And in that case, most of the time, the force is gravity. All right. Now, let's look right here. And you can see that we have object A and object B. Object A is traveling with positive constant velocity, but the vectors are smaller, so this means that it is slower. Object B is traveling with positive constant velocity, but the vectors are longer, so that means it's faster. What you need to pay attention to also is that object B starts at the origin, while object A starts above the origin. So if you pay attention to the graph here, you can see object A starts at the origin. Object B starts at the origin, and object A starts above the origin. So that's how you would graphically represent a motion map. Please let me know if you have any questions.